Perfect. So yeah, my name is Uwe Steinkraus. I work for a company called Unified Automation. We are doing toolkits and software libraries to implement OPC UA technology into existing products, into existing software. Today, I want to give you a very short, brief overview on the technology. And I want to start with the information model, then look into the access types. We have different access types, client server and pub sub. Then I want to talk about a little bit about the protocol bindings and make a very, very short view into the discovery services. This slide we have already seen. I want to concentrate more on the picture here. So it's OPC UA is all about a device that exposes data and a system that's going to consume the data. So the communication is one part, and the other part is the exposure of the information. And for that, we have the information model. It's an information-centric layered architecture, as you can see here on the picture, and I want to go through that picture in my presentation here. The OPC Foundation has defined basic rules for exposing information with OPC UA, and we have a generic object model which has an extendable type system. And the OPC Foundation has already created built-in models for data access, for alarms and condition, for historical data and historical events. We have a built-in model for programs, and we have also a core specification for the device description. So the OPC Foundation has defined the rules and some information models already. Those we call the core information models. Everything in OPC UA is based on the nodes and references. So it's an object-oriented information model, and this is the base, let's say, the tool box you have to describe your information. So everything in UA is a node, and UA defines an extensible list of 8 node classes. And from this node classes, you can derive, or you can use directly, or you can derive and create your own type system and your own nodes. All the nodes in the address space are interconnected through references, and those references can be hierarchical or non-hierarchical references. And with that, you can describe every system or every kind of information. To give you a more detailed example here, on the lower end in gray, we have the object type of an analog measurement. It's in the built-in information models. And as you can see here, I have the type modeled with different objects, with different alarms. We have a level alarm here, a high level and low level alarm. And of course, the most important of an analog measurement is the measurement itself, which has then properties like an instrument range or an engineering unit. And this is a description of the type. And of this type, the OPC server can then have multiple instances. And they all look the same, but then they are filled with concrete values. So the yellow box, you can see I have 3 different instances. I have 2 temperature and 1 pressure, and it looks exactly the same. So what is the advantage of that? The advantage is that a consumer of the information can specialize on the type. For example, a graphical display element. And if that is specialized on the type, it can automatically show the values. And it can be, of course, of different style. So it's a different specialization on the type, but it will also be filled with the same values. So with this system, We have a very powerful instrument to describe information and to specialize on information. In addition to that, and on top of this core information models, we have the companion models. So the OPC Foundation collaborates with different organizations and domain experts, and the OPC Foundation gave them the mechanism how to describe the information, and the domain expert now define what to describe, like robots, vision system, injection molding machines. And we have collaborations with a lot of organizations that have already done this. I think we have about 50 or more companion specifications ongoing. And on top of that, you can even define what you want on top of that. So this is the layered architecture of the information description, all based on the mechanism OPC gives you. So the information model is object oriented. We can describe any kind of complex data. We expose the data and the metadata, so there's no additional configuration or information needed. Everything is inside the server. It is a full mesh network, and it is interconnected with the references to express the relations of the data. And the base model and the modeling rules are defined by the OPC Foundation, and all the rest is coming from others. Now I want to talk a little bit about the access type. So it's a little bit comparable. So we have two experts, we have two types of access into this information. So on the one side, we have the client server model, and on the other side, we have the pub sub. It's a little bit like with a telephone call where you have a private conversation, which you can have with multiple, of course, at the same time with multiple people. And on the other side, it's a little bit like a webinar where you have one person talking to a broker or directly, and all the others are just listeners. These are two different use cases, but both are covered by OPC UA. To go more into detail here, you can see that we can have communication on a client server side, but also on pub sub to exchange data, and we can do an aggregate, which is more or less like a broker. And so we have the client server and the pub sub, and they can do the communication for all different kinds of use cases. The client server communication is based on TCP on a request response. And we have a connection where the client and the server exchange the data. We have a notification for data change. We have a keep alive mechanism, so the client and the server can see vice versa if the other side is still alive. This sort of communication requires some resources, and so it's probably good suitable if you have less than 500 connections running. And the use case is the asynchronous communication for huge amount of flexible data. So each client can ask different information on the server and will get that information. This is typically used for the SCADA HMI use cases, also for IT and cloud communication, and so that's the use case range where you use the client server communication. The publish subscribe communication is a little different. It's based on UDP, and it's a message system where the publisher sends a message or multiple messages to the subscriber, and it's a fire and forget transportation. It's more like a public session because there's one talking and multiple people listening. It has low resource consumption if you have many subscribers, and if you have over 1,000 that consume the same data, the publish-subscribe mechanism is a suitable one. You can also use it for cyclic communication, and there we use it with the TSN to make it deterministic. So the use case is a synchronous communication, small amount of fixed data typically. You can also use that through a broker, and then you can use this with the cloud. So the use case is the field level communication and also the cloud communication. In addition to that, we have now the services which are protocol independent, and the services is a client-friendly abstract API to access the information in the server. The OPC Foundation has defined 36 services, and they're grouped into sets of functionality. So we have secure channel services, session services, node management services, attribute services, which are probably the most interesting because that's the read and the write of the values. We have a method service set where we can invoke methods, and also a monitored item and subscription service set where we do the notifications of data and events. So this is the access model you can see here in red and in the red box. The PubSub on the other side is an extension, and it extended the OPC with a model for configuring what is going to be published or subscribed via an application. So we have a generic PubSub information model, and we have a configuration where you can configure the connections, the metadata, which is a description of the content of the data that is sent, and the data set itself, which is the content. And also the security configuration goes through this configuration model of PubSub. And the data and event notifications you can get through the client server mechanism, but you can also get them through the PubSub. So this is an extension, but it's not changing to any existing that we had before. The PubSub communication model was introduced with the version 1.04 in the OPC specification. Now I want to talk a little bit about the protocol bindings. So on the client server side, we have the UA TCP, which is mandatory. It's a binary encoded information, and it's transported over TCP. We also have a hybrid protocol binding, which is binary encoded messages that use a TLS transport. So you can run it over HTTPS, for example. And we also have a WebSocket communication, which is a JSON encoding, and it also uses a TLS. So this you can use for the client server. For the PubSub, we have also protocol mappings, and there are different use cases. There's the one-to-many use case, the cloud, and the deterministic use case. And so we have different protocol mappings here. And most important, the UADP, which is a binary encoded message that is running over UDP. It's a UDP multicast. So it goes out from one and can be received by many, many others. And in addition, we have a JSON encoded message that we can run over MQTT protocol, which is typically used in the cloud. And we can also use the UADP, so the binary encoded over TSN, which then becomes deterministic and can be used for the field level communication. We have a different talk about that later on. So this is for pre-configured data content that forms a message for the certain use case, and then we use the protocol that we need to reach the consumer of the data. Now I want to talk a little bit about the discovery mechanism. So OPC UA has or comes with a mechanism to figure out what OPC servers are installed in the network or even on a certain computer. So there's the LDS, the local discovery server, which is a list of servers that run on one computer. And if there's only one server running, then this LDS functionality is inside the server itself. In addition, we have what we call the LDS ME, the LDS with multicast extension, that gives you additional information. It typically runs in a subnet, and it shows all the servers that are available in that subnet. The LDSMA has additional features like name resolution, and it works without any infrastructure, so it's a zero conf mechanism. So the LDSMA, they can exchange the information who's in the network between themselves, and with that you only need to reach one LDSME, and then you will have the picture on all the OPC servers available in the network. For an OPC client, this is transparent. So the OPC client just says, find servers on network or find servers, and then it will get the complete list of servers available. In addition to that, we have what we call the global discovery server. This is a security management, and it's also an OPC server. It's a list server that has all the features for listing and giving you information on the OPC servers available, but also manage the security of those. And it can encapsulate an external certificate authority, and it can push and pull certificates for the servers and the clients. So the complete security management of an OPC UA infrastructure can be done with this GDS. The security, we will have a talk right after this one. That's why I'm not going into this. So we have different security concepts, and it's all integrated into the basic architecture of OPC. We will see some more features upcoming in the next few days. More talks about that, key attestation and provisioning. So OPC UA is also taking care about the things around the pure communication itself. So how, for example, the initial configuration of this security is done, what to do when changing a defect device, that we can reuse the configuration but not reuse the identity, of course, for security reasons. All this OPC takes care on. Also about the firmware upload, download, secure boot strategies. The different working groups are working on that, and you will hear talks about that in the next few days. As a summary, and that's why the picture is a little bit bigger now, there's one information model. We have two access types, the client server and the pub sub, and there's 3 or even more protocol bindings that we select depending on the use case we need to fulfill. So the information model is object-oriented, flexible, and extendable. We have the client server and the pub sub, and the protocol we have the TCP based, we have UDP based, but we can also run over MQTT with a JSON encoded for the cloud, and we can optional also use brokers. And in addition, we have the discovery and the security features of OPC. With that, I thank you for the attention and hand over to Derek.